Hello, math application students. Today we're going to talk about 7H, which is about tree diagrams. So let's start off with this example. Carl is not having much luck lately. His car will only start 80% of the time, and his motorcycle will only start 60% of the time. Okay, so let's draw a tree diagram. So if we're talking about the car, I'm going to use the letter C. If we're talking about the motorcycle, I'm going to use the letter M. So if the car starts, I'm going to put a C. If the car doesn't start, I'm going to put C prime. Now the car is starting 80% of the time. So if it starts 80% of the time, what's the percentage do you think that it doesn't start? 0.2, right? Because these two have to add up to 1. Now, what about if the motorcycle is working and if the motorcycle is not working? Well, they said the motorcycle will only start 60% of the time. So we know that that's 0.6. So if we know that's 0.6, what does this one here have to be? You got it, 0.4, because it either starts or it doesn't start. The only chance that these have to add up to 1. Okay, same thing here. This is 0.6, and this is 0.4. Okay, so how many different ways are there? There's this way, this way, this way, and this way. So I could do the probability of car intersection M, and that would be 0.8 times 0.6. I could go this way, the probability of the car intersection M prime, which is 0.8 times 0.4. I could go this route here, the probability that the car doesn't start, but the motorcycle does. That's 0.2 times 0.6, and then the probability that neither of them start, the probability that the car doesn't start, and the probability that the motorcycle doesn't start. That's 0.2 times 0.4. So, and so we've got 8 times 6, we get 0.48. 8 times 4, and we get 32, 0.32. 2 times 6, we get 0.12, and 0.2 times 0.4, we get 0.08. Now, if we add all those together, what do we get? We get 1.0. All of these have to add up to 1. So this is the first one here is the probability that the car and the motorcycle start, both. This is the probability that the car starts, but the motorcycle doesn't. This is the probability that the car doesn't start, but the motorcycle does. And this is the probability that neither of them start. So now let's answer the questions. Use the tree diagram to determine that both will start. So the probability that both start is going to be equal to 0.48. Okay, and the probability that that he can only use the car is going to be what? If he can only use the car, that means he can't use the motorcycle. So car only, I'm going to say 0.32. I don't use this because this is the motorcycle and the car. You could use both of them. This is the probability that he can only use the car. Okay, let's look at the next example. Okay, you've got a jar of marbles. Jar A contains 2 white marbles and, two white discs and 3 red discs. Jar B contains 3 white and 1 red disc. A jar is chosen randomly from flipping a coin. 1 disc is chosen at random. Determine the probability that the disc is red. Okay, so if we're flipping a coin, then we've got a 50-50 chance that we're going to use jar A or jar B. Does that make sense? You flip a coin, you're either going to use jar A, jar B. Now, if I'm using jar A, you're either going to pick a white disc or a red disc. Now, how many discs are there total in jar A? 2 plus 3, which gives me 5. So my denominator is going to be 5. How many white marbles? There's 2. How many 3 discs? How many red discs? There's 3. So I've got a 2/5 chance of getting a white disc and a 3/5 chance of getting a red disc. That adds up to 1. Okay, now in jar B, has 3 white discs, 1 red disc, so the total number of discs is 4, isn't it? Okay, and I have a 3/4 chance of getting a white disc and a 1/4 chance of getting a red disc. Okay, a jar is chosen at random. Find the probability that a red disc is chosen. Okay, now there's 2 possible ways to get a red disc. I could get jar A and a red disc, or I could do jar B and a red disc. So I need to figure out this probability, which is jar A and a red disc, and this probability, which is jar B and a red disc, and add those together, and that's the probability of getting red. So we've got, okay, instead of writing 0.5, I'm going to call this 1/2. Since I'm using fractions anyways. Okay, so it's 1/2 times 3/5. This is jar A and a red disc. And then if I go this route, jar B and a red disc, it's 1/2 times 1/4. So let's add these together. So this gives me 3/10, and this gives me 1/8. Okay, well, we need a common denominator, don't we? So what are we going to do? We could multiply this one by something. Yes, I would multiply this one top and bottom by 4, and this one top and bottom by 5. So then we get 12/40 plus 5/40, which gives me 17/40. And that is the probability of getting a red disc. All right, let's do another example. Okay, a box contains 3 red, 2 blue, and 1 yellow marble. Find the probability of getting 2 different colors. Okay, so first we're going to do with replacement. So red, blue, yellow. Okay. So how many are there total? 3, that gives me 6, right? So I have a 3/6 chance of getting red, 2/6 chance of getting blue, and a 1/6 chance of getting yellow. Okay, now what we're going to do first with replacement. So if it's with replacement, then we got all these different possibilities, right? So if we go red, then these fractions all stay the same. 3 over 6, 2 over 6, 1/6. 3 over 6, 2 over 6, 1/6. 3 over 6, 2 over 6, 1/6. Okay, so the probability of getting two different colors. Okay, so I'm either going to get a red and a blue, right? That's this pathway. Or getting a red and yellow, which is, instead of, well, okay, 3/6 times 1/6, or you can get like a blue and then a red, which would be 2/6 times 3/6, or we could get blue and a yellow, which is 2/6 times 1/6. I can go this route, which is a yellow and a red, so which is 1/6 times 3/6 plus, I can get a yellow and a blue, which is going to give me 1/6 times 2/6. Okay, is that all the possible combinations of getting two different colors? Red and blue, red and yellow, blue and red, blue and yellow, yellow and red, yellow and blue. Okay, so we have 6 different possible combinations. This first one gives me 6 out of 36. Second one gives me 3 out of 36. The next one gives me 6 out of 36. This gives me 2 out of 36. The next one gives me 3 out of 36. And the last one gives me 2 out of 36. And all of that adds up to 6 and 3 is 9, 9 and 6, 15, 17, 20, 22. 22 out of 36. Okay, now that sounds fine, but what if we don't, if replacement doesn't occur? Okay, because that will sometimes happen in your homework. So what does that mean? If replacement doesn't occur, that means that when you pull out the marble, there's one less marble in there. So I'm going to redo this. Okay, so if replacement doesn't occur, then we still have the red, yellow, and blue. We still have 3/6 chance, 2/6 chance, and a 1/6 chance of red, blue, and yellow. But once I've picked out, let's say I've picked out a red. If now, how many marbles are left? Okay, if I've picked out a red marble, how many red marbles are there left? You got it, 2, because you've taken a marble out. And if I've taken a marble out, how many marbles are there total? 5. you've taken a marble out, so the denominator has decreased by 1. Are there still 2 blue marbles? Yes, so that's 2/5. And then there's still 1 yellow marble. Do all of these add up to 1? 2/5 plus 2/5 plus 1/5? Yes, that adds up to 1. I know I've done it correctly. Okay, now if I've picked a blue marble, if I pick the blue marble, now I've taken that away and it's gone away. There's still 3 red marbles, so it'd be 3 out of 5, 1 out of 5, because I've taken a blue marble away, and there's still 1 yellow marble, 1 out of 5. Do all 3 of these add up to 1? 3/5 plus 1/5 plus 1/5. Yes, those all add up to 1, so that still works. Now this last one here, if I picked a yellow marble, then I could get a red marble, a blue marble, or a yellow marble. Okay, so if I picked a yellow marble, then we have 1 marble less, but I still have 3 red marbles, so this is going to be 3/5. I still have 2 blue marbles, so it's going to be 2/5. And since I had 1 yellow marble and I've taken it out, I've got 0/5, right? Or 0 yellow marbles. So 3/5 and 2/5, this adds up to 1 also. Okay, so the probability that I get 2 different colors. Okay, so just like previously, I could either get a red and a blue, I could get a red and a yellow, I could get a blue and a red, I could get a blue and yellow, I can get yellow and red, I could get a yellow and blue. Okay, so we have 6 different things to add up, and our denominator is going to be different than the previous one, because all of these, when you do without replacement, that means you've reduced the number of marbles, and the denominator is now 5 on all of these. So let's get all these together. So this first bit, 3/6 times 2/5 is going to give me 6 times 5 is 30, right? Plus 3/6 times 1/5 plus 2/6 times 3/5 plus 2/6 times 1/5. Okay, the yellow path, 1/6 times 3/5. The blue path, 1/6 times 2/5. Okay, so this is the yellow path. That times that is going to give me that. That times that gives me this. Here's the pink path. Here's the orange path. Here's the yellow path. Here's the blue path. Now let's add those all together. Okay, so 6/30 plus 3/30 plus 6/30 plus 2/30 plus 5/30 plus 2/30. And we get 6 plus 3 is 9, 9 plus 6 is 15, plus 2 is 17, plus 5 is 22, 24/30. Okay. And Did that work? Okay. I think I made a mistake somewhere. Okay, well, if I did, you need to tell me what my mistake is. But these are the different paths, and to get two different colors. You need to remember that the denominator decreases by 1 because you've taken a marble out. Okay, let's do this last example. A bag contains 5 red marbles and 3 blue marbles. 2 marbles are randomly selected from the bag. Determine the probability at least one is red. Okay, so you're either going to get a red marble or a blue marble, right? 5 red marbles, 3 blue marbles, total 8 marbles, right? Okay, 5/8 chance of getting red, 3/8 chance of getting blue. 2 marbles are drawn simultaneously from the bag. That means it's pulled out and removed. Determine the probability that you get at least one red. Okay, so now I could possibly choose another red, or a blue, or a red, or a blue. Okay, so I've taken a marble out. My denominator is 7. If I've taken 1 red marble, what's my numerator there? You got it. It's going to be 4 because I've taken 1 red marble out. We still have 3 blue marbles. Okay. Now, if I've taken a blue marble out, there's still 5 red marbles, so 5/7. And if I went this way, if I've taken a blue marble out, how many blue marbles are left? You got it, 2 out of 7. These 2 add up to 1, these add up to 1, these add up to 1. Okay, now the question says, what's the probability that at least one of the marbles is red? Okay, so which pathways have at least 1 red marble? Well, this one has 2 marbles, so at least 1 is red. This pathway has at least 1 red. And lastly, this pathway has at least 1 red. So we need to calculate the yellow, the red, and the blue pathways and add those together. So we got 5/8 times 4/7 for the yellow pathway. The red pathway is 5/8 times 3/7. And then the blue pathway is 3/8 times 5/7. And each of those pathways has at least 1 red marble. So let's calculate this. We got 20/56. We've got 15/56. And we've got 15/56. All right, 15 and 15, that's 30, plus 20 is 50, so I've got 50 out of 56 is the probability. And remember, probability is always less than 1. So when you're doing probability, you have to get a fraction less than 1. Now we could simplify this, right? I could say it's 25 over 28. So either answer is fine. If you want to simplify it, great. If you want to leave it non-simplified, that's fine. Hope this helps you with your homework. Email me if you have questions.